Hello and welcome to Unit 7, Part 1. My name is Mr. Bell, and today we're going to talk about parallel and perpendicular lines, and then we're also going to write the equations of some of those lines. On this slide, we're asked to determine which of these lines are parallel. Recall that parallel lines are kind of like railroad tracks. They never intersect, they are equidistant or the same distance apart. And it's pretty easy to recognize if lines are parallel when looking at a graph or an image of them. But sometimes you're given them the lines in equation form. Well, here's how you tell if lines are parallel in the equation form. Parallel lines will have the same slope or the same rate of change. They kind of have the same meaning. And recall that in a linear equation, y equals mx plus b, the m is what stood for the rate of change or the slope of the line. So you've got to evaluate and look at all of the equations you're given and see if any of these have the exact same slope. So look at the first line here. It says y equals 3x plus 2. The slope of this line is 3. Second line, if we look at the slope, y equals mx plus b, the slope of the second line is a negative 3. So those two are not parallel. The third one is not in slope-intercept form. It's actually in standard form at the moment. So we need to convert this one to slope-intercept form. I'm going to do that by adding 3x to the left side to cancel it, add 3x to the right side to move it over. Now I'm left with y is equal to 3x plus 10. And I can figure out what the slope of this line is. It is a 3. So now that I have all the slopes available, which lines have the same slope? Well, that would be our first line and our third line. They both have a rate of change or a slope of positive 3. Thus, those lines are parallel to each other. On this next slide, we're asked to write an equation for the line that is parallel to y equals 2/3 x plus 2 and passes through the point 0, 5. Now remember, for writing the equation of the line, we need our answer in y equals mx plus b. I like to sometimes think of it as y equals a box x plus a box, meaning I've got to find those two things. I've got to find the slope and the y-intercept before I can write the equation of that line. So let's kind of begin. First thing I need to look at is that it's parallel to this line, and recall from the last slide, parallel lines will have the same slope. So that alone helps me figure out half of my answer. I know that the slope of the line that I'm trying to find has the same slope as this one, which is 2/3. Next part can be a little tricky. I need to find the b. I need to figure out what the y-intercept is in my equation, not this one. My line's just parallel to that line. Well, think about it like this. Wouldn't it be nice if they gave us an x and a y value and you could plug in those values and solve for what's missing? Hey, they did. You've got to be able to start noticing when they give you a coordinate or a point, they're not only giving you the point 0, 5, they're giving you an x and a y value that is a point on that line. So let's see if we can use that. So I'm going to come over here and write what I know so far. Y equals, I know the slope is 2/3, x plus b. But I'm trying to solve for this b. So in place of the x and y, I'm going to plug in the x that they gave me and the y that they gave me. Okay? So the y they gave me in the question was a value of 5. So 5 equals, the slope was 2/3 times x. The x value that they gave me in this problem was a 0. And then I'm going to bring down the plus b. This will allow me to solve for what my y-intercept is. 2/3 times 0 is 0. It cancels out. I'm left with 5 is equal to b. And that is what I need to go in the box over here for the y-intercept, for the b. So my final answer of the line that is parallel to the line they gave me and passes through the point 0, 5 would be y equals 2/3 x plus 5. We are being asked which lines are perpendicular. Perpendicular lines, recall, meet each other at 90-degree angles. They almost make they make a plus sign when they cross. So it's pretty easy to see perpendicular lines when you have a graph or an image, but what about when you have an equation? Well, recall that parallel lines, the equation, the slopes were the same. Perpendicular lines, there's a couple ways you can think of it. Their slopes are what's called opposite reciprocals, which means you can take the slope of one line, flip it and change the sign, and that will be the slope of the other line. Another way you can think of it is the product of the two slopes will be a -1. So let's look at some examples down here at the bottom. If I have a slope of 2/3, well, the opposite reciprocal of that would be if I flipped it and changed the sign. So if I have a line that has a slope of 2/3, a second line that has a slope of -3/2, those two lines are perpendicular to each other. So let's take a look at our examples up here and see if we can figure this out. The slope of the first line is 2/3. The slope of the second line is 3. And the slope of the third line is -3/2. So what I need to do now is compare the slopes of all of these and see which ones are, if any, are opposite reciprocals. So let's take this 2/3 on this first one. If I flipped it and changed the sign, we did that example here at the bottom, the line that's perpendicular to this line will have a slope of -3/2, and that matches our third one. Our middle line here of 3 is neither parallel nor perpendicular to either of the other two lines. So to tell if lines are perpendicular, you look at the slope, the line perpendicular to it, you'll take that slope, you'll flip it, change the sign. It's also called finding the opposite reciprocal. On this last example, we're asked to write an equation for the line perpendicular to y equals 5/2x minus 10 and passes through the point 5, 4. Well, remember, before I'm finished, I need to fill in those boxes. Y equals box, x plus box, which those two boxes stand for the slope and the y-intercept that I need to find. So if I'm looking at this line they gave me, my line that I'm trying to find is perpendicular to this line. So I'm going to take this slope that they gave me, which was 5/2. I am going to flip it, which is to find the reciprocal and opposite. So it was a positive to begin with. I'm going to turn it into a negative. So if my original slope was 5/2, the slope of the line perpendicular to that line would be -2/5. So I'm halfway through, but now I've got to find the b. And recall from one of the previous examples, it's nice when you have an x and a y value that you can plug in here and solve for what's missing and solve for your b value, and you are. They gave you a point. They gave you an x and a y value to use to help figure this out. So I'm going to come over here to the side. In place of the y, I'm going to plug in the 4, because that's my y value from the point they gave me, is equal to -2/5. That's the perpendicular slope to the one that they gave me. I'll plug in the x value. They gave me a 5 for the x value. And plus b. Remember, the b is the part that I'm looking for. Once I solve for the b, I'm finished with my problem. So let's continue working this out. 4 equals -2/5 times 5 leaves me with -2 plus b. And now I'm solving for b. I'm going to cancel this -2 by adding 2 to the right side. To keep it balanced, I'm going to add 2 to the left side, leaving me with 6 is equal to b. And since that's what I'm looking for, I'm going to plug a 6 into that box. Now I'm finished. The equation of the line that is perpendicular to the one they gave me, but passes through the point 5, 4 would be y equals -2/5 x plus 6. All right, thanks for watching and hope this helps.